Section 6.5 is on solving square root and other radical equations. A radical equation has a variable in the radicand or a variable with a rational exponent. To solve one of these, we need to follow the following steps. Isolate the radical, or the variable with the rational exponent, to one side of the equation. Raise each side of the equation to the power suggested by the index. Solve the remaining equation, and always check your solution, because sometimes if you have two solutions, one or both may not actually work. I'd like to take a look at 4 examples here, and I know that's quite a few, but there's a lot of different things that can happen when you're solving equations like this. So my first example is the square root of x plus 4 plus 6 is equal to 7. First thing I need to do is isolate my radical, so I'm going to add 6 to both sides. So I have the square root of x plus 4 is equal to 1. Now when I square both sides, I get x plus 4 is equal to 1. And then subtracting 4 on each side, x is equal to negative 3. Now I need to check this, and in order to do that, I'm going to plug in negative 3 for x into the original equation. None of these steps that I did, always the original equation. So is negative 3 plus 4, square root of negative 3 plus 4 plus 6 equal to 7. And remember that when you're checking, you don't like add or subtract on either side of the equation. You just kind of PEMDAS each side. So is the square root of 1 plus 6 equal to 7? Indeed it is, because 1 plus 6 is equal to 7. So this does check. So my one solution is x equals negative 3. Our second example says 2 times the quantity, x plus 3, raised to the 2/3 power equals 8. So I would like to isolate the stuff in parentheses. So I'm going to divide both sides by 2. So x plus 3 to the 2/3 power is equal to 4. Now I need to get rid of that 2/3 power. I'd want that to be a power of 1. So I'm going to multiply each side, raise each side of the equation to the 3/2 power. Because over here, recall the property of exponents. It says if I have an exponent inside and one outside, I multiply. So that's going to give me a 1. So this side of the equation is going to just become x plus 3. And that's equal to, I need to figure out what 4 to the 3/2 power is. So remember, that would be the same as saying the square root of 4 to the 3rd power, which is the square root of 64, which is equal to 8. So solving the equation now, x is equal to 5. So let's check that and make sure that's true. So is 2 times 5 plus 3 to the 2/3 power equal to 8? So is 2 times 8 to the 2/3 equal to 8? Well, 8 to the 2/3 is the same as, I can write 8 as 2 to the 3rd power to the 2/3 power, and again multiplying the exponents there, that's going to give me 2 to the 2nd power, because remember this is like 3 over 1, which is equal to 4. So this is going to be 2 times 4 is indeed equal to 8. This one checks, and my one solution is x equals 5. Let's take a look at example number 3 here. So I have the square root of 5x plus 14 is equal to x. Squaring both sides gives me 5x plus 14 is equal to x squared. And what I have here is a quadratic equation. In order to solve a quadratic equation, it needs to be equal to 0. So I'll subtract 5x on both sides and 14 on both sides. And then I will factor that, and that's going to give me x minus 7 times x plus 2. So my two possible solutions are x equals 7 and x equals negative 2. And I do need to check both of those. Particularly when you come up with two solutions, one of them might not check. So let's plug 7 in first. So the square root of 5 times 7 plus 14, is that equal to 7? Is the square root of 35 plus 14 equal to 7? And indeed it is, because that's the square root of 49 is equal to 7, so that one checks. Let's try negative 2. is the square root of 5 times negative 2 plus 14 equal to negative 2. So actually right now I can tell that's not going to be true because I can't take the square root of something and get a negative number. But let's go ahead and work this out. So is the square root of 10 plus, negative 10 plus 14, is that equal to negative 2? And the square root of 4 is not equal to negative 2. Remember, we're looking for the principal square root. So negative 2 does not work, and 7 does. And our last example here is a whole lot of fun because I actually have a square root on both sides. So I can't actually isolate the square root. I'm just going to dive right in and square both sides. Okay, now what does that mean on the left here? That means I'm going to have 2 plus the square root of x minus 6 times 2 plus the square root of x minus 6. And yes, that has to be FOILed. And over here it's really easy. That's just x plus 10. I do need to FOIL this. Looks confusing? Let's just take it one step at a time. First, 2 times 2 is 4. Outer, 2 times square root of x minus 6 is just 2 square root of x minus 6. Inner, same thing, plus 2 square root of x minus 6. And last, square root of x minus 6 times square root of x minus 6 is just x minus 6. Okay, let's clean that up a little bit. So this is going to give me a negative 2. And then these two terms are with radicals. I just add those. So 2 square roots of x minus 6 plus 2 square roots of x minus 6 gives me 4 square roots of x minus 6. And then I have this random plus x. And then don't forget I had an x plus 10. Okay, now I have one square root in my equation, so I can isolate that. Notice that when I subtract x from both sides, the x goes away. I'll add 2 on both sides, so that's going to give me a 12. And then I'll have 4 square root of x minus 6. Divide both sides by 4. Square root of x minus 6 equals 3. Square both sides. X minus 6 equals 9. And add 6. X equals 15. Okay, one answer. I do need to check that. So is 2 plus the square root of 15 minus 6 equal to the square root of 15 plus 10? Is the square root of is 2 plus the square root of 9 equal to the square root of 25? Yes, 2 plus 3 is equal to 5. This works, and I have one solution. So in this section we took a look at radical equations and equations that have variables raised to a rational exponent, how to solve those, and the one last thing I really want to say is you have to check your solutions, particularly if you end up with two solutions.